Hi everybody, we just wrote down the notes for how to find the area of a triangle in our notebook, and now I'm going to do a little bit of explaining. Okay, on the screen right now you'll see that there are three different formulas written down. We have the top one, the middle one, and the bottom one. Now here's the deal. All three of these formulas really get you the exact same answer. The top one requires you to use order of operations with parentheses. This is the one you're going to see written out the least. This is the most elementary and the least commonly used, okay? This right here, the one in the middle, with the base times height on the top, it is implied, and you have to infer, that you are going to find whatever the base times height is first and then divide it by 2. So these first one and the middle one are the same exact formula, just written in a different way. Now, the bottom one is going to be the formula you see most often in high school and college and later on in life. The reason for that is when you multiply something by 1/2, you will get the same answer as if you divide it by 2. Okay? So that works for any unit fraction. A unit fraction would be like 1/2, 1/3, 1/4, 1/6, 1/7, 1/100th. Okay? So if you multiply something by a unit fraction, you will get the same answer as if you divide by its denominator. So if you multiply by 1/2, you get the same thing as if you divide by 2. If you multiply by 1/4, you'll get the same answer as if you divide by 4. And that's why you're going to see two different formulas, okay? All the same thing, still get you the same answer. All right, let's move on and talk about these triangles for a little bit. Okay, so the good question here is, why do we divide by 2 when we find the area of a triangle? So I have two different triangles here on the screen, and I've got grid paper behind the triangles so that you can see the individual units. Now, when we look at this triangle on the left, by the way, it's a right triangle, even though it's on the left, and it's a right triangle because this forms a 90-degree line right here. What we can do is a right triangle, if we were to add in these red dotted lines, if we were to continue to draw the exact same kind of triangle, we would end up with a rectangle or square. It looks, hold on, let me see it, I can tell you. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So even though it may not look like it, because both the sides are 6, this is going to form a square, okay? That is why we can multiply the base of the square of the rectangle, the base of the triangle times the height of the triangle, because that's the same thing as multiplying the base of the square versus the height of the square, which is what we've been doing. We divide by 2 because we only have half of the square. So that's why we divide by 2. Basically, we have a red triangle and a white triangle, and they're supposed to be the exact same size. I couldn't make it exactly perfect, but I tried. This is one reason why we divide by 2. And that makes a lot of sense, especially if we have a right triangle. But what about if we don't have a right triangle? So over here on this side of the screen, on the right side of the screen, this is an isosceles triangle. The reason this is an isosceles triangle is because this side, the right side, and the left side are the same. And to be an isosceles triangle, you have to have two sides the same. Well, a lot of people would look at this and say, well, there's no way that this is going to make a rectangle. It's actually not true. You just need to expand your mind a little bit. If we were to draw in these blue lines like this, you will see that we now have a rectangle. Here's the tricky part. These two triangles, if you were to put them together and flip them upside down, would be the same size as this triangle right here in the middle. So again, that's why even with this weird triangle that's not a right triangle, we can still divide by 2. Okay, now here we have some other quadrilaterals. It's really simple when we have rectangles, but what about these parallelograms and trapezoids? Why do we use base times height? And then why would triangles have anything to do with this? Well, the first thing I'm going to show you is some purple dotted lines that show you the different types of triangles you can get in quadrilaterals. So give me a second because I got to do some clicking. So with our rectangle, we can do diagonal to diagonal. That would give us 2 right triangles. With our parallelogram up here at the top, we could go that way and we'd have 2 triangles. We could go this way and we would have had 2 triangles. I now have 4 triangles. We could technically find the area of each individual triangle. It would be the same thing as if we did base times height though. Down here in this trapezoid, I could go that way and have 2 different sized triangles, or I could go that way and have 2 different sized triangles. Now, it's important to know none of these lines are symmetrical. So taking it back a long time, if we folded these shapes wherever these purple lines are, they would not be the same. The only quadrilateral that would work going diagonally would be a rhombus or a square. And the reason it works for rhombus and square is because they have the same length sides. Okay. Now, we've been using base times height. So why does base times height work for these funky shapes? I should have showed you this a day ago, but honestly, I forgot. So here's why it works. If we were to take and cut a purple line right here and cut off this little triangle of the shape, so cut off this purple triangle. If we then moved that purple triangle over to this side, like that, I now have from this purple line to this purple line a rectangle. That's why we can use base times height. Same thing happens down here with our trapezoid. If I were to draw this red line right here and get this red triangle, if I were to flip that triangle upside down and move it to the right, we now have another quadrilateral. So that is why rectangles, squares, parallelograms, trapezoids, and rhombuses are all really connected to triangles. You can always get 2 triangles out of almost all quadrilaterals. Now notice I said almost all because there's always a little time where it won't work, but most of the time it works. So what this little video should have taught you and what you should understand from this video is that, hold on, let me go backwards, that we divide by 2 because there are 2 triangles in most quadrilaterals, and that is why the formula works.